All right, so what we're going to do today is we are starting one of our count them, 4 units on triangles. Triangles are, in fact, my favorite shape because they are the strongest shape in nature. So I'm really excited for the next 4 units because we get to do all of the stuff about triangles. I love triangles. Unfortunately for me, my favorite is trigonometry, and that's the last triangle unit. Okay? So what we're going to do is we're going to start by classifying the triangles. So again, 3 acute angles. If all the angles are less than 90 degrees, we simply call that an acute triangle. All right? Mathematicians are super creative in the way they name things. So if we have an obtuse angle in our triangle, well then we call that an obtuse triangle. Now, you can only have one obtuse angle in a triangle since the angles add up to 180. You still need, you can't have 2 obtuse angles that will only add up to 180, okay? Because the biggest angles that you can have, that you have 2 of them to match, would be 90. And you can't have 2 90-degree angles in a triangle either, okay? All right, so when we have a 90-degree angle or a right angle, we simply call that a right triangle. And finally, when we have 3 congruent angles, we call that equiangular. Or equiangular, it doesn't matter how you pronounce it, as long as you know that 3 congruent angles is equiangular. One thing to remember is anytime you have an equiangular, they are always 60 degrees. Okay? They are always 60-degree angles. You can put that as a note or you don't have to, but it's not a bad idea. So we're going to do a little bit of practice with this. I'm going to be using the highlighter tool so that I can highlight the triangles as we go. So the first triangle we're going to look at is triangle CDE. And of course, just like with angles, we start at the first letter and then we follow it around, C, D, and then E. So that's my orange triangle for me. And that is a right triangle. Triangle CDE is a right triangle. We can see it from this box right here. Okay. The next triangle we're going to look at is triangle BCE. And we can see that we can see that angle BCE is larger than 90 degrees. So that is going to be an obtuse triangle. Now, earlier today, my students did want me to prove it. So let's check and make sure. You don't have to do this. I'm going to just do it real quick. All right. All right. So one thing we can see is this line right here in the middle represents our 90 degrees. We can see that angle BCE exceeds 90 degrees and is therefore obtuse. All righty. Next on our list is triangle ABE. So that's going to be this one right here, ABE. And that is going to be an equiangular triangle. Because again, all 3 angles are congruent. All right. Next is triangle BDE. And again, we can see this one, we don't have to measure it because they gave us a 90-degree marking right here. We can see it is bigger than 90 degrees. So we know that this is going to be also an obtuse triangle. And our last one is angle C or triangle CFE. It is definitely acute because we can see that CEF cuts through the 90-degree angle. All right, so just like we can classify our triangles by their angles, we can also classify our triangles by their sides. So we can see these little tick marks. Remember, the tick marks means congruent. So for the first one, we have 3 congruent sides. So that tells me we call this an equilateral triangle. Okay. Whenever we have 2 congruent sides, we call those an isosceles triangle. Okay. So equilateral, equi meaning equal, lateral meaning sides, equal sides. Isosceles, iso means same, skeles means legs, same legs. And then anytime we have a triangle where they don't give us any information about the sides, we assume they are all different, and therefore we call it scalene, okay? Unless it labels them as congruent or they tell us the side lengths and we have some that are congruent, we assume the sides are not the same, okay? Unless the angles are marked congruent, we assume they are not congruent, unless we can prove that they are. There are times where we might have an angle that's not marked, but we have to prove that it's congruent, okay? All right, let's put this into practice. So we're going to look at triangle JKM. That is the whole image here. So J, K to M. And again, because LM and NM are not labeled, we're going to assume that they are not the same as KL or JN. We can so we can call this one a scalene triangle, as all 3 sides are different. Next up is our KLN, which has 2 congruent sides, and so therefore is going to be isosceles. Like I said, I know that C I'm not sure why, but my battery on my microphone died, so it looks like I have to re-record this part. So again, we're gonna we got to KLN being an isosceles triangle. That's this purple one right here, and then JKN, which is this blue one right here, and that one's going to be equilateral. All right, numbers 9 through 11, we're looking at each of these. So on number 9, we see that 2 of the sides are marked congruent. It's a right triangle, so therefore isosceles right. On number 10, we are given an obtuse angle. And given they don't tell us anything about the sides, we can assume that they are not congruent. So therefore, we are going to put this as a scalene obtuse. This one right here, number 11, all the sides are equal, so it's equilateral. And all of the angles are the same, so it is equiangular. It is also good to note that these 2 are always the same. They're always together. So equilateral is always equiangular. Okay. Number 12, we were given 3 different sides. They are all different sides, so they are scalene. And then we did measure this angle right here, the biggest angle. I know it's the biggest angle because it's across from the biggest side. We will go into more detail about that in the future. But again, in class, we did go ahead and measure this using the protractor just to confirm that we're using an acute angle and not an obtuse angle, because it's not a right angle. Otherwise, they would tell us that it was a right angle. If they don't tell us it's a right angle, we have to either measure it and find out, or we have to assume it's not. So if we look here, this black line right here indicates where the 90-degree marking is. My triangle's on the inside of that. It's a little less than 80 degrees. So that's just something to keep in mind. Right, so then the next one we have is scalene right. Again, no side lengths are mentioned, so therefore we assume it's a scalene. And they give us that it's a right angle, so it is a right triangle. And number 14, they tell us that these two sides are both 5 feet, which again means they're congruent. And then they give us that this is a 97-degree angle, and that means it is obtuse because anything over 90 degrees is obtuse. Moving right along, in class we did number 1 and number 5 on solving sides with algebra. I do have all of the information for the other 3 problems. So on number 1, it wanted me to solve for both x and y. Since the triangle is equilateral and side AB is 49 degrees, that means that side BC and side AC are also both 49 meters. So when we solve for x, we put 3x plus 1 equals 49. If we subtract 1, we get 3x equals 48. And then we divide by 3 and get x equals 16. For y, we have 18y minus 41 is equal to 49. And then we added 41 to both sides, giving us 18y equals 90. Divide both sides by 18, and you get y equals 5. Right, and on number 5, it says if WXY is an isosceles triangle with WX is congruent to XY, segment WX is congruent to segment XY, they want us to find X and then the measure of each side. So first, I took the 2 congruent sides, WX and XY, and set them equal to each other. I added 77 to both sides, giving me 6x equals 3x plus 81, subtracted 3x from both sides, and then divided by 3, so we got x equals 27. And then to plug in for the sides, wx equals wxy, so I solved with the easier problem. 3 times 27 was 81, plus 4 is 85. So xy is 85, wx is 85, and then wy is 5x minus 31. We have 5 times 27, which is 135, minus 31 is 104. They did not give me units on this one, so therefore I am not required to give units. And again, on this one up here, where yes, they did give me units, the reason I didn't include units is that I wasn't finding a side length, I was simply finding a variable. So keep that in mind. All right, so that's everything we had for this section of the notes. We will continue on next time with the triangle sum theorem. Talk to you later. Bye.